Hi, my name is Alwyn Joseph, and this is my submission for Video Assessment 3C. The question asks, you throw a ball at 20 meters per second at a 40-degree angle from the horizontal. Starting at 2 meters above the ground, the ball lands on a flat 5-meter-high roof. How long is the ball in the air, and how far in the x direction does it travel? Granted that the ball lands on the roof and doesn't hit the wall. So, what we know so far is that the ball is thrown at a 40-degree angle, and h1, height 1, is going to be 2 meters. And then the initial speed that the ball is thrown at is 20 meters per second. And I labeled point A, B, and C. A is going to be the maximum point of the parabola of the flight path. And at A, the y component, or the acceleration, the velocity of in the y direction is going to be 0 meters per second, because it'll stop going up and it'll be right in the middle at that point. So what we're going to have to find is the initial velocities in the x direction and the y direction. And we can use this using vector math. So in the y direction, it's going to be the initial velocity times sine theta of the angle. So it's going to be 20 meters per second times sine 40. And then for the x, it's going to be the same thing, but just cosine 40. And we know that in the x direction, has no acceleration. But in the y direction, the acceleration is going to be negative g, gravity. And we can use one of the kinematic equations to look at how it would work. So Vy at the maximum point of the graph is going to be Vy minus gravity times 1. And we know this is equal to 0. And we can rearrange this whole equation to get T1 equals Vy over g. And then we can plug this in. We can plug in values. So we know the velocity is 20 meters per second sine 40 degrees over 9.8 meters per second squared. That's going to give us our first time of 1.31 seconds. This math right here was defined from point N to point A. Now, to go from point A to point P, we're going to have to use another equation. Vy max squared is equal to y squared. Over 2g. We know that Vy max is equal to 0. And we know that at point A, the height of the ball is AC, as shown on the diagram. The height of point P so the SY, the vertical distance, is going to be Y max minus 5, because it's going to be 2 minus 5, which is the initial height and the final height. And so we can plug everything into an equation. This is going to be 0, so you can cancel this out. This is going to be multiplied by 20 sine 40 all over 2 times 9.8 minus 3. Doing all the math for that, Vfy is going to equal 106.47 rad meters per second. And from this is going to be the velocity as it hits the final point at P. And so what we can do is find time 2. And rearranging this, time 2 is equal to 9 divided by 9.8, and that's going to be 1.053 seconds. And so the total time is going to be time 1 plus time 2. The total time is going to be 2.37 seconds. And we can use that to find the distance traveled. Since the x velocity is constant, there's no acceleration on it, we can just do s of x equals u of x times total time, which is equal to 20 cosine 40 times 2.37 seconds. And that will give you the final answer of 36.23 meters. Thank you.